So we are going to be talking about variables in Rust, but first of all, let's create a new cargo project. We are going to name this cargo project variables. Let's change directory into this project, and then let's open it up in VS Code. Let's open up the main.rs file that is located in the src folder. Clean this up. So let's talk about variable bindings in Rust. Variable bindings in Rust allow us to assign a name to a value. This value is going to be stored in memory and we can access it later on using that name. We usually declare variables in Rust using the let keyword. So for example, if we want to create a variable x, we are going to say let x and then we'll add the type annotation. I'm using an unsigned 8-bit. So we are going to learn more about types in upcoming videos. Equal to, and then let's give it a value of 10. We can print this out using print line, macro, and curly braces with x in it. This text I just used now with curly braces is known as interpolation. Interpolation is a fancy way of telling the browser to add whatever is in that variable to this string and print, and since we're using the print line command, print whatever is there. So whatever value is in x, since x is equal to be 10, it's going to add it to the string. Since we're in the variables folder, we are going to run this code using cargo run. 10 is displayed to the terminal because we asked it to print x. Another concept we are going to learn about is the fact that by default, all variables in Rust are immutable. This means their values cannot be changed once they have been assigned initially. If, for example, we try to make x, let's say 20, this won't work. Since the variable can only be assigned once, it's going to throw an error. So if we try to run the code using cargo run, an error is going to be thrown. This error is going to tell us that cannot assign twice to immutable variable. So if, for example, we try to make it work or to carry out operations like to add or change the values, we are going to assign the mute keyword. This mute keyword in Rust lets the variable become mutable. So we should save this and try to run it. Once we run it, we are going to see that 20 is being printed out, and it's still going to tell us that maybe it is overwritten before being read. This is not an error, this is a warning. This warning lets us know that you did not use the value 10, but you just changed it to 20 immediately, and not by adding or anything. You created another assignment before using that value. So we can solve this by putting print line and then carry out our interpolation and printing x before we change it again. So now I'm going to name the first x an initial assignment and the second one the second assignment. Since it's two assignments that is being done, we are changing the value completely, not adding it. And now we are going to remember that at the end of every statement, you add your semicolon. So we are going to clear this and run this again using cargo run. And we can see that initial 10 is printed and the second assignment 20 is printed. So we can also prevent doing this or just following the right method by just making x equal to 20, since we are not going to use the value 10 initially. And remove the mute keyword. Since this value we are not going to change it, it's ideal we remove the mute keyword and just make it not mutable. So we are going to learn about a concept known as shadowing. Let's create a code block. So a code block in Rust is created using colon braces. Even a function is a block of code. A code block is just basically a group of statements. So if we now want to talk about shadowing, if for example create a value x with an unsigned 8-bit and make it 30, we want this to be that x is going to be in this code block. That means after the execution of this code block, x is going to be 20 back. But in this code block, let x be 30. We don't want to make it mutable. and we don't want to change the name of the variable. So this is known as shadowing. This means that the inner x is going to overshadow the outer x, and x is going to be 30. So if we run this using cargo run, we are going to notice that inside is going to be 30 and outside is going to be 20. This is because the inner variable overshadows the outer one. This is shadowing. S overshadows the other x. After its code block is executed, the inner x dies, so it goes back, or x goes back to being 20. If you add a mute keyword when overshadowing, since this variable is not going to be mutated, it's going to throw an error. So let's run this using cargo run. And we'll notice that since it's not going to be mutated, it's going to throw an error. Remove this mute. There was no mutation done. We only just shadowed it. And since that shadowing is not mutation, it's rather a second assignment, but in a different code block. So it's still going to run, but the warning error is going to be thrown. So when overshadowing, remember to remove the mute keyword, since shadowing just uses the same variable name, but does not mutate the variable. It does not change the variable, just uses the same variable name. So now we are going to learn about constants in Rust. So constants are variables that won't change within the entire code. They are constant variables such as pi, or maybe number of students in class you're going to use in a project. So how do we define constants in Rust? We define constants in Rust using the const keyword and then the name. And then one thing about constant, that type annotation is compulsory. We are going to use an F32 or float 32-bit. And we are going to give it a value of 3.14. Remember your semicolon. So we are going to print this normally, like how we print our normal variable to the terminal output. So print this using print line. So print this using print line. So let's run this. Clear the terminal and hit run it, cargo run. We are going to notice that 3.14 is being printed back to the terminal. So what makes constants different from variables? Constants are values that won't change. They are forever immutable. You cannot change them by adding a mute keyword. And constants can also be added in anywhere in the scope. If, for example, we move this constant outside our main function, paste it here, our code should run normally, because constants exist outside the function scope and can also stay within or outside any block scope. So if we run this code is supposed to run properly. You notice that the code is going to run successfully. So this is going to be all for today's video. You can learn more about it by following up on this series. Our next video is going to be on functions.